Okay, so like I said, this is the sort of thing you need to remember. So if you have the PDF, you can find E of x and you can find the variance of x from that. And then, but if you have a probability you need to find, or you need to find a percentile, you need the CDF, and you get that from the PDF. Right then, so let's start off quite nicely, and I'm going to struggle for pens again and go to bed. So let's do 2x plus 3 for 0 less than or equal to x less than or equal to 1, and we'll have this being just, should we have, so 6x squared, because why not? And then between 1 and 3, and then 0 elsewhere. So this is a multi-step PDF. So I'm going to ask for the CDF, so a big F of x. I might ask for E of x. I won't go for variance, just keep things simple for now. And what should we do? Should we find the percentile? Should we find the median? So find the median as well. Okay, so here is the distribution, and again, before I can even use this, I do need to normalize it. So timesing it by some normalization constant k, and we have that the integral from 1 to 0 of 2x plus 3 dx plus 6 times plus k times 6x squared dx must equal 1. So we get that this is k times by x squared plus 3x evaluated between 1 and 0 plus, and then this would be 2x cubed evaluated between 3 and 1, yeah. And then this is equal to 1 because we need it, the sum of the probabilities to be 1. So this would be k times by 4, and then k times by, and I need this between, I should probably write that as a square bracket so it doesn't look like I'm doing it to the power of 3. So 27 times 2, so 54, take away 2, so 52. 1. So 52k and 4k, so k equals 1 over 56 in this instance. So k is equal to 1 over 56. And yeah, you could argue that it does simplify on this one here. I wouldn't personally in this instance. Just keeps it simpler having both of these out of 56. It'll make our calculations easier later. Right, so let me just double check I've done this correctly. So 4 take away 0, great. 27, 54. And 2, yep. Okay, I think we're good, yep. Okay, so we've got our distribution normalized, so now let's find big F of x. Let's find the CDF, the cumulative distribution function. Right, so we do, for the multi-step one, you have to do it each range individually. So if we take a look at what it's going to look like, so this would be 2x plus 3, so it starts at 3, and it goes across like that from 0 to 1. And then from here, it takes the form of an x squared graph. So it might not necessarily be at this height, it could be piecewise, it could be like that. So the point being that we have this thing that we need to find the area of. Well, we need to find a function that will map the area to some point x. Right then, so if our area is in this first region, it would be the integral from x to our lower bound of the function it's under, which is 2x plus 1, so 2x plus 3 rather, so 1 over 56, and then 2t plus 3 dt, so this would be 1 over 56 t squared plus 3t evaluated between x and 0, so this would be x squared plus 3x over 56, and that's our first part. So our big F of x is 0 for x less than 0, and now we know that it is x squared plus 3x over 56 for x in the range 0 to 1, and now we need to do the middle bit, so x greater than 3 would be the next next bit. Okay, so now in this range 1 to 3, so x in the range 1 to 3. So now we assume that x is here. So do we agree that it would be the area of this first block plus the integral for this second bit, right? So what would the area of this full block be? It's this one. We use our last function that maps up to x and make x 1. So the integral between 0 and 1 would be this evaluated at 1, so it's 4 over 56. So in this case, yeah, so f of 1 plus the integral from x to 1 of, it would be 6 over 56, and I am keeping this at 56 for a reason, and you'll see in a sec, of t squared dt. Right then, so f of 1, so if we go over here, we can actually evaluate f of 1, so that's 4 over 56, and I believe that to be 14, yeah. But I will be keeping it as 4 over 56 for the moment, plus 6 over 56 times by t cubed over 3, and this would be between x and 1. So something I can, you don't have to do this, but you should. It's a good way to make this easier. Do you agree that I can take this over 3 outside and cancel it with this 6? Again, that's the smart thing to do here. So this would be 2 over 56, then t cubed. So it's 4 over 56 plus 2 over 56 times by x cubed minus 1. And so this would be 2x cubed minus 2 plus 4. So 2x cubed plus 2 over 56. And so we get 2x cubed plus 2 over 56 for the range 1 to x less than or equal to 3. And the way you can check they are correct, so if I put in my full value 3, so if I evaluate f of 3, what should the full area be at this point? Should be 1, right? So let's check it. So which range does 3 fall into? Falls into this one. So 3 cubed is 27, times by 2 is 54, plus 2 is 56 over 56, so 1. So that is how I know what I've drawn there is correct. Okay, so that's my CDF. Right then, let's calculate E of x. So E of x, which one does it use? Does it use small f of x or big F of x? So do I use this one or do I use that one? Yeah, use small f of x, exactly. So E of x is, it's x we're after, so it would be the integral over the range when we times everything by x. So in this instance, it's the integral of 2x squared plus 3x over 56 between 1 and 0, and then plus the integral from 3 to 1 of 6 over 56. Now, you can see why I kept it out of 56 for this bit, because it just keeps the whole thing out of it, and it's the same thing here. You don't have to. The questions they make will work a bit nicer, but anyway. So it would be x cubed dx, and let's find it then. So 1 over 56 times by, so 2x cubed plus 3x squared over 2, evaluated between 1 and 0, plus 6 over 56, then x to the 4 over 4, evaluated between 3 and 1. So it would be 1 over 56 times by 2/3 plus 3 over 2, and then 56, 5 over 56, and it would be, I'd like to take the quarter out here, to be honest with you. Yeah, I think I will actually take the quarter out, so it would be over 4, so that will be 224, yeah, so that'll be out of 224 there. And then this is just x to the 4, evaluated between 3 and 1, so what's that, 81 take away 1, yeah, much easier. Okay, so this would be 4, 9, 11 over 6, so 1 over 56, and then 11 over 6, plus 480 over 224. I'll level with you when you get to this point, just check it in your calculator and just do this for the sake of it at this point. So your e of x would be 1 over 56 times 11 divided by 6. I was not expecting it to be anything nice. And then plus 480 over 224. So I get the expected value to be 2.18. And again, using understanding, does this answer make sense? If you consider my range of values, yeah, I would say so, makes sense. Right then, and then the last one's the median. So which of these would I use? Which of these would I use for the median? I use this one or this one. So it would be that one over there, because that one tells you how far through you are. Right, so there is this idea of percentiles becomes a bit harder now for multi-step ones. So do we agree that what the median actually means is when it's essentially when big f of x equals 0.5, right? Okay, so for the median means that big f of x equals 0.5 when you're at 50%. Whenever you're through, if this whole thing is 1, where's 50% at, essentially? Right. Why is that much more interesting for a multi-step PDF? Because normally you would just go, oh, it's this equals 0.5 and solve it. Why is it not so straightforward now? Yeah. Do you know which one you should make equal to 0.5? That's the problem, right? So, which of these two ranges, so out of this range or this range, which one contains the median? And you have to work out which one it is. Anyone think of a way how we could work it out? So the way I would do it, I would look at this one, and I would see what's the most it could be. So degree the most this could be is when it's 1. And degree that be 4 over 56, which is nowhere near a half, right? So degree the half must be, halfway mark must be in that one. That's the idea. So if this was over half, degree it must be in that one then. So that's how you check effectively. So we get that 2x cubed plus 2 over 56 equals 0.5. And so 2x cubed plus 2 equals 28. Yeah. And so we get 2x cubed equaling 26, and so x cubed equals 13. So x is the cube root of 13. That would be a median. So your median is at 2.35. Okay, for the same one then, if I were to just, because I've done those 3 now, if I were to ask you for, say, the 10th percentile, just out of interest. So when f of x equals 0.1, which of these would you use? So the maximum here is 4 over 56. If I do 4 over 56 in my calculator, that's 0.07. So the maximum percent that gets you is 7%. So again, degree the 10% mark would be that one. Degree won't always be that one. You have to check. But yeah, you would use this one again, that one do it again. There you go. Right then, the new thing I want to talk about is if they give you the CDF to start with. So if they give you the CDF to start with, and this is quite nice if they do, honestly. Then what they will do is they will ask you for E of X. They'll ask you for E of X, and they're kind of hoping you just use that to find E of X. So you'll need to find the PDF and then use it to find the E of X. So with that in mind then, I've removed the PDF. Let's see if we can get back to it. How do you think that we get back to the PDF from that? So think about how we got there. What do we do normally to get that? We integrate, right, between x and 0. So logically, how are we going to get back? Differentiate. Yeah, differentiate it. And the thing is, this one is made by f of 1 plus the integral. But what is f of 1? Just a number. So when you differentiate it, it will disappear anyway. So going backwards, f of x is equal to, so 0 for x. Actually, I'll just do the first one first. I'll set it up like a normal PDF. So it would be 2x over 56 plus 3 over 56, which is 2x plus 3 over 56, which is exactly what we started with. And that was in the range 0 to 1. And then this harder one, so 2x cubed plus 2. So this would be 6x squared over 56, and then plus a constant, so the constant goes. And again, it's exactly where we started. And then from here, you can now start to calculate E of x or whatever. But it's about knowing what you need for what, effectively. Right, so with that done, I believe we are now ready to actually have a proper go at one of these. So I'm just going to give you a try and see what you think. So 2023, and we'll do statistics A, and I'm pretty sure, yeah. So this one here gives you the CDF to start with, but let's start it out in the right way. So show that B equals 4. So where is B here? So where is B here? It's this range here, right? So B is the maximum. Okay, I want you to show that B equals 4. So finding K is a bit different with the CDF, because you just expect to realise that if you evaluate it at the top of your range, it should be 1. Right then, so showing that B is 4 is quite straightforward. So if we're using f of B, B is in this range, so we use this one. So what should this equal if you make B xB? What should it equal? 1, right? So 1 over 480 b to the 4 plus this equals 1, you solve it. And then you've got the CDF, so you can use this to find the probability. So this one here, x is less than or equal to 2.5. Which range does 2.5 fall into? If b is 4, obviously it falls into this one. You use that one. Write down the lower quartile. So the lower quartile is when big f of x equals 0.25, and you do it. And this is from 2 years ago's exam. And then find the 3 significant figures, the value of k that satisfies the equation. That one is a bit harder, but I'll leave you to try it. Have a go. So you can definitely do A, B, C, and D. So that is what? 8 marks, and then there's 4 marks for the last bit. So there's 4, 5, 12 marks there. So I'll give you 12 minutes, given that it's like a fair question, I'd say. And I will just turn the camera up slightly. No, not catch you in it. Let's see if I can help it. Okay, so if you're watching at home, you can now pause it, and now I'm going to move it back. And again, be careful with your lower quartile, because you have to check what one you can fall into. 2 more minutes. So writing this out then. So you're given that the CDF is given by 0 for x less than 0. You're given that it's x over 4 for x in the range 0 to 2. And then it's 1 over 480x to the 4 plus 7 over 15 for x in the range 2 to b. Yeah, x in the range 2 to b. And then 1 for x greater than b. Right, so let's get started. Show that b equals 4. Show b equals 4. Well, b is the maximum of the range, so if I evaluate this at b, it should equal 1. So 1 over 480 b to the 4 plus 7 over 15 equals 1 plus 750 over 15, yeah. Yep, okay. So this would be 1 over 480 b to the 4 equaling 8 over 15. And then timesing by 480 on both sides. I get 256, I'm guessing. Yeah. And then b equals 4. Okay, nice and straightforward. And then part b, so now that I know that b is 4, I'll set this in. Okay, so find the probability that x is less than or equal to 2.5, so this is just f of 2.5. 2.5 falls into this range here, so this is equal to 1 over 480 times 2.5 to the power of 4 plus 7 over 15. So 2.5 to the power of 4, 480 plus 7 over 15. I get 0.548. Do you get that? Anyway, write down the value of the lower quartile. So lower quartile is when f of x equals 0.25. Right then, so let's check this one. So if I evaluate this at 2, do we agree it would be a half? So the lower quartile is in this one here, because this gives you a half at its absolute most. So yeah, the lower quartile will be in that one. So x over 4 equals 0.25, and our lower quartile is x equals 1. Should be nice and straightforward. Part D then, so the upper quartile is when f of x equals 0.75. And so we know from this that this was equal to quite literally a half. So we know that the median, the upper quartile must be in this one. So we get that 1 over 480 x to the 4 plus 7 over 15 equals 0.75. And I'm just going to rearrange this, so 0.75, take away 7 over 15 times by 480. So I get that x to the 4 is 136, so x is equal to the 4th root. 136 times by 480 is 136 over 136, so 3.41. So the upper quartile was 3.41. Okay, so part E, that is the only one I would consider difficult. Did either of you get an answer for it? No? Did you get an answer? Okay, let's see. So, find the problem. So you need to find a value k such that that's equal to that. Right, so let's start with the obvious then. So this would be 1 minus the probability of x being less than or equal to 3.5. So this is 1 minus f of 3.5. So let's find that. So 3.5 falls into this range, so we use this one. So it'd be 3.5 to the power of 4 divided by 480, and then plus 7 over 15. So I get 0.1, so it'd be 1 minus 0.7793. So 1 minus answer. Okay, so I get that 0.2207 equals the probability of x less than k, and the trick here is that this is the same as that. Right then, so we get to this, and how do we deal with this? Do you agree it's just a percentile? This is basically just saying what's the k would be the 22nd percentile, effectively. So which one of these would it equal? This one or this one? Which one has the 22% mark in it? Do you agree with the first one? Yeah, so it equals k over 2. So 0.2207 would equal k over 2. If it was in the other, if it was in that range, so if it was so obviously this, the maximum this range has is 0.5, so it's 2, so 2 over 4, 8.5. If this was equal to something bigger than that, you'd have to make it equal to the second one. But anyway, we get k equaling 0.4414. Is that what you got? You got it. Oh, nice. Yeah, so k was 0.4414. Right then, I got one more for you. So, unfortunately, because of the way the new spec works, it's actually quite annoying. So they don't write questions like this anymore, where they've got A, B, C, D, and E. They'll give you it like this, where you get it, and then you get a load of space for one, and then a load of space for another. So what I'll do is I'll write the question on the board, and I'll write all the, you can get started with part A. I will write all the stuff they want on the board. So the question is 0, and then for x less than -2, and like I mentioned when we started this, x can absolutely be negative. It's for 1 to 2. Okay, so part A wants the upper quartile. Part B wants small f of x. Part C wants the expected value. So it's 5 marks, 4 marks, and 4 marks again. Yeah. 5, 4, 4. 13 minutes. So 5 marks for this, 4 marks for this, 4 marks for this. But there's a part, it's 2 for this. So interpret your answer in context. So you'll get it. So if you look at what x actually is the amount, how early or late he closes his podcast. So if x is -1, he closed it a minute early. But if x is 1.5, he closed it a minute and a half late. So for example, if your e of x ends up being like negative, you'll say on average he closes early. If it's positive, on average he closes late. That's the context. So you have to like look at what x actually is, essentially. classroom. So like the last one, I don't think there's anything too like off the bat. So like that last one we did, it was like a hard question at the end. I feel like all of those things there are very standard things to find. So hopefully 13 comfortable marks. Wait, am I? Oh, hang on. On the last one, I've made a stupid mistake. It's x over 4. This would be over 4 here times 4. I'm an idiot. So it'd be 0.8828. Sorry, yeah, I made a stupid mistake there. I just misread the thing. Sorry about that. Same idea. I just made a stupid mistake there. Right, look at the long video. Great, fantastic.